So why we need to go for a compass surveying? Okay, the first and foremost reason is whenever the area of survey to be done is large and the number of details that can be acquired in the survey is limited because of some obstructions, then we need to go for compass surveying instead of chain surveying. Because in chain surveying, what we are doing, we are dividing the whole area into some set of triangles and then measuring the length of the sides and doing the area when we are doing the area calculations. But when it is not possible to divide the area into set of triangles, okay, because of large undulations or because of crowded details, like suppose there are many boulders present in between, or when there are already existing houses in between where it is not possible to do the chain surveying, okay, then in those cases we'll be going for the compass surveying, which consists of taking the angles as well as measuring the distances between the given selected points. Okay, so generally, the principle of chain surveying is triangulation. That is, we divide it into multiple set of triangles. The whole area, survey area is divided into set of triangles. Whereas in compass surveying, the principle of compass surveying is traverse. Okay, so what we'll do is we start at one point, and from that one point, we'll identify the second object. We'll bisect the second object using the compass. Then again, we'll shift the instrument from this first point to the second point, and then we establish the instrument at second point, and then we bisect the third point. Once this third point is established, again we'll measure the distance between second point and third point, and again we'll be shifting the instrument from second position to third position. So again at third position we'll be establishing the instrument, then again we'll be bisecting the fourth point. Okay, we'll be measuring what is the angle from third point to fourth point, and we'll also measure what is the distance. So what is happening here? We are moving around the area to be surveyed. Okay, we are not working in between. Okay, these are the end points, or these are the points along the boundary of the area I need to survey, and I'm shifting my instrument at multiple locations on the boundary of the area to be surveyed, and I'm simply taking what is the angle between two given points and what is the distance between two given points. Okay, so I'm reducing the number of the amount of work that need to be done in the field. Okay, at the same time, I'm increasing the quality also, because I'm measuring the angle, also I'm measuring the distance. So what happens in chain survey when you are measuring only the distances? If there is if there is an error in measuring the distance, if you are calculating any angles from that, again it will lead to errors. But here you are measuring the distance as well as you are measuring the angles. So if at all any mistake has happened in either of the things, then you can simply rectify it in the field itself. Okay. Suppose I have started. Assume that I have started at this point. I have then taken the reading at this point, at this point, at this point. Again, when I'm coming back here, okay, the distance when I'm seeing from this point, last but one point, the starting point, the distance should be same, as well as the angle should also be the same, because this point is already established in the field. Okay, so that is a correction that we can check in the field itself, and if at all any mistake has occurred, then we can adjust the errors along across all the station points, and then we can close the survey there itself and calculate the areas, etc. kind of thing. Okay, so the traversing can be of two types. One is closed traverse, that is wherever you are starting the surveying, you are going to end the survey again at the same point. So what happens in the closed traverse is, when I'm starting my surveying here and when I'm ending here, if at all any mistake has occurred, okay, the end point will not come on the first point. There will be a error. Suppose assume that the end point is going to come here itself. Okay. So what does this mean now? There is a difference between the starting point and the ending point. Means some error has occurred at either of these station points. That is why I'm not able to close my work again at the starting point. I may be doing a mistake in measuring the distances either in between second and third point, or fourth and fifth, anywhere, or continuous error also I can make in all the segments, or I can even mark this point with a wrong angle. Assume that my required angle is 110 degrees. I might have marked it as 109 degrees 40 minutes, or 110 degrees 20 minutes, or 120 degrees 40 minutes. So if at all I make a mistake here in either measuring the linear distance or making an angle, definitely it will be clearly visible to you here. You will not be able to close the survey at the starting point. So this portion, what you are going to see, is called as a closing error. Okay, this itself indicates what is the accuracy of the work you have done in the field. Okay, so this is called as a closure traverse, where the starting point of the survey and the ending point of the survey should coincide. Okay, if they coincide, then it's a clear indication that the whatever work you have done as part of this compass survey in the field is 100% accurate. Okay, but what are the possibilities? Can we get 100% closure traverses in the field? Okay. Sometimes it is possible, but most of the times it is not possible, because whenever you are doing the survey, if at all there are any magnetic items nearby your survey area in the form of high tension electric wires or in terms of magnetic cores, etc., kind of thing, okay, definitely there will be variation in the angle which you are seeing, because the compass which you are using consists of a magnetic needle. So if at all there are any magnetic items which can attract the needle towards its side, it will show you the wrong reading. Okay, even your smart watches also has an impact on the magnet. Okay, if you are having a smart watch, or if you are carrying a ranging rod nearer to the compass, or if you are holding any metal item nearer to the compass, also definitely there will be variation in the angles which you are observing or which you are fixing in the field. So that is why in practice, getting a closer traverse without any error is not at all possible, except unless and until you take all these measures. No metallic items nearby, no high tension wires nearby. Okay, if you take all these measures, then there is a possibility that you will be getting the exact closure traverse. But most of the cases you will be getting an error, and that error is called as a closing error, which you need to again adjust, or which you need to redistribute along all the sides. Okay, if assume that uh, there is a linear error of 1 centimeter here. Okay, this error is called as closing error, and if there is a error of 1 centimeter here, so what you need to do now, it has gotten shortened. Okay, so you need to increase this line by 1 centimeter, right? So you can't increase this line by 1 centimeter, the last line. 1 2 3 4 5 6 sides are there, 1/6. Okay, what, how much you will be getting? 1/6 means approximately 0.16 mm. Okay, so 0.16 mm you need to adjust along all the sides, then only this end point will come and meet this point. Okay, similarly, if there is any variation in the angle, instead of 110 degrees, if you got the angle, final angle as 109 degrees, then you need to divide that 1 degree difference divided by 6 sides, and you need to adjust your line with the respective deviation. Then only you can close this traverse at the same starting point, otherwise you can't close. Okay, and the second type of traverse is called as open traverse, where you'll be starting at one point and you'll be ending at the other point. So technically, you can't see that the starting point and ending point are falling at the same place, but it should be mathematically closed. So what do we mean by mathematically closed? So I'm starting my survey at this point. From this point to second point, I've done my measurement, linear measurement as well as angular measurement. Again, from second to third, I've done. Third to fourth, I've done. Fourth to fifth. So this fifth point should be an already established point, whose position in terms of linear distance as well as whose position in terms of angle, angular value is known to me. Okay, so if these details, the last point detail is already known to me, what I'll do from this last but one point, I will sight this object using the compass. Okay, as I know already at what angle this object is situated in the ground surface, when I sight from this point, I should get the same distance. I should get the same angle, and I should also get the same distance. Then only I say that it is a mathematically closed open traverse, which can also be considered as a closed traverse. Okay, if it is not matching, or if you are not closing this traverse at a known fixed point, then it is called as a open traverse. If you are closing this at a known fixed point, then it can be treated as a closed traverse only, though the name is open traverse, but mathematically it is closed. That is, you are ensuring that the survey is done accurately. Okay, so in a basic open traverse, you can't estimate the survey, you can't give assurance of the quality, but in a mathematically closed open traverse, you can give the accuracy. Okay, so this is the concept. So we are moving around the required boundary by means of making linear measurements as well as angular measurements, and then we are going to determine what are the areas enclosed in between. Okay, so this concept is called as the traversing, and this is the principle of your compass survey. Okay, so these are part of your sum of Viva questions as well as some short answer questions also. What is the principle of chain surveying? Triangulation. What is the principle of compass surveying? Traversing. Okay. And what is the principle of surveying? Working from whole to part and establishing a new position with respect to two different measurements. So all these principles are different. So you should not get confused. Okay. This is what I explained to you. No? So basically, we have two types of instruments which we use in the compass surveying. One is the prismatic compass, and other is the surveyor compass. In our lab, we have both the instruments, but mostly we'll be using the prismatic compass. So we need to have a tripod. Okay, so this is how we place the compass. This top portion, which is in the cylindrical form, is there. It is called as the prismatic compass, and this is the three legs which you are able to see. It is called as the tripod. So you need to fix this tripod at the station at which you want, from where you want to take the measurements. Okay. Then you need to do the centering, leveling, and focusing. So I'm first placing the three legs on the ground. On that three legs, which is called as a technically called as a tripod, I'm fixing the prismatic compass. Okay, there will be a small button, a combining button at the bottom of the prismatic compass. Just you need to insert that there. Okay, and you need to rotate it so that it gets fixed. Okay, but you need to handle it very gently. Okay, so after placing that, we need to do some temporary adjustments at every station. Whenever you are moving the instrument, we need to definitely do some adjustments. So those three adjustments are called as centering, leveling, and focusing. So centering is operation when you are fixing this tripod legs on the ground. Okay, the center of this tripod legs, that is, here you are able to see some black notches, right? Black portion. Okay, the center of this black portion should exactly fall on the peg which you have placed in the ground. A peg will represent your required station, A, B, C, D, E, whatever we are calling as stations. So you need to drive pegs at A, B, C, D on the ground. So after I fix this tripod, if I drop a plumb bob, or if I hold a stone at the bottom of this black portion and drop it, it should exactly fall on the peg. That means, because why? What it indicates, when you drop any item, okay, it will definitely travel only in the direction of the gravity. Okay, just you throw any item onto the top surface, onto the sky, it falls only in the direction of the gravity. That will be a vertical direction always. Okay, so that is how you need to do the centering. Fix a peg first, which indicates your station point. Then adjust your tripod in such a way that whenever a plumb bob or a stone is dropped from the bottom of this tripod, it exactly falls on the peg. If it doesn't fall, then you need to adjust your tripod legs, moving it rotationally. Okay, hold only one leg of the tripod, move it such that the center point falls onto the peg below. Okay, or if you are not able to get the center point by moving this leg, then move the other leg. Okay, so using your common sense, you need to decide which leg has to be moved towards which direction, towards left or right, so that the center point of the tripod as well as the peg coincides. Okay, so this whole process is called centering process, and this need to be done whenever you are shifting your instrument. If you are taking measurements only from one instrument, it is sufficient if you do it for once. But if you are doing a traversing, okay, then in this case you are seeing how many A, B, C, D, E are there. So at all five stations, you need to do this temporary operations, adjustments, centering you need to do, leveling you need to do, and focusing you need to do. Okay. So once I fix that centering, okay, then what I need to do is the leveling process. Okay. The leveling, you are seeing you're seeing a circular box here, right? So when you fix it to the tripod, there is a possibility that the compass may slide on either of the sides. Okay, so you need to hold the two ends of the compass, the circular compass, and you need to adjust it very gently so that the compass is looking at a level surface or flat with respect to the ground surface. Okay, there should not be any inclination when you fix it to the tripod. You fix it on the tripod, move around 2 to 3 feet away from the tripod instrument, and check whether the top surface of the compass is whether flat or it is gently sloping towards any of the sides. If it is flat, well and good. If it is gently sloping towards any of the side, simply adjust the adjust the instrument, that is, press the instrument to which side it is at a higher elevation. Okay. So that is called as the leveling operation. Then the third one is the focusing of the prism. You can see there is a prism here. Okay, this one. This one is a prism. So why this prism is used in prismatic compass is the circular graduations which you are able to see here. Okay, these are engraved in a reverse fashion. Okay, man, normal ga రాయకుండా reverse లో రాస్తుంటాయి ఈ numbers. So that is the reason why we are using a prism. When you are seeing from a prism, the reversed value will look as a straight value to you. Okay, so that is the purpose of prism. So what you need to do here is, you can see here this is a prism, and here there is some arrangement which is used to move it up and down. You can move the prism up and down. So just by adjusting this movement, adjusting by this arrangement, you need to move the prism up and down till you are able to see the values which are engraved on this circle very clearly. Okay, so the focusing of the prism is dependent on the human perception. If my eyesight is very good, if I am able to clearly distinguish the features in the compass, I can simply adjust by within one time. But if a person is having a poor sight and if he is not able to read the values accurately, okay, he need to adjust it till he is convenient to see the values. So when I am doing the work, if I adjust the prism to my eye level and say it is good, okay, the other person can't claim the same thing. So he also need to check it through the prism whether he is able to see the values clearly or not based on his eyesight. Then again he need to readjust the prism, or he need to refocus the prism till he is able to clearly see the values. So focusing of the prism is definitely a function of the human being. It can't be the same. Okay. So these are the three temporary operations that we need to do whenever you are establishing your compass in the field. Okay. So this is the pictorial diagram. So one is needle. Okay. So this is the needle. This is the magnetic needle. Okay. Then you have a pivot here. That is, the needle is placed on some support. This sharp triangular edge which you are seeing is called as a pivot. I will just cover the important things in this. Okay. And this is the slit through which you are able to bisect the given object. Okay. And this is a shadow. Okay. Mirror. If sometimes what happens is, if you want to avoid sunshine coming onto this prism, okay, or coming onto this glass, because compass, the top surface of the compass is glass. If there is direct sunlight falling on that, and if when you are seeing from the prism, you will not be able to clearly see. Okay, for those reducing those kind of effects, you can see even take the help of the mirror. Okay, and this eighth one is the prism through which you are going to see. Okay, and this ninth one is the eye vein, that is the slit or a hole from which you will be seeing the given values through the prism. Okay, so these are few important things which you need to remember, and these will be asked in the Viva also. Okay. So this is the basics of your compass surveying and the prismatic compass. We also have a surveyor compass. The main difference in surveyor compass and prismatic compass is, I'll explain again, but the first basic difference between a prismatic compass and surveyor compass is, for a prismatic compass, you need to have a tripod. For a surveyor compass, you need not have a tripod. Okay. Remaining we'll see later, differences later, we'll see the differences. But let's today learn what do we mean by bearing and how to observe the values. Okay, how to observe the values using a compass. Basically, first of all, I want a clarification from you. What do you mean by an angle? What do you mean by an angle? I want the answer for this. What is an angle?
Sir, it's a just vertex point of two rays, sir.
No. Many times you say cos angle, sine angle, right? Cos angle, sine angle, tan angle. What is that angle? Normal angle.
Inclination,
Inclination with what?
the base, sir.
Inclination between
Component.
two rays, sir.
So it is a deviation in the direction of two rays from a common point. Okay.
Yes, sir.
Suppose you are having 2 points. Let's assume that I'll show here only. So you are having two different lines starting from the same point. Okay, this is the common point, and this is the direction of one line, and this is the direction of another line. So the difference in the directions of two lines sharing a common point is called as an angle. Okay, but using a compass surveying, we are going to determine what is the bearing. We are not finding out the angles. We are finding out the bearings. Once we go further into these topics, we'll know what is the difference between a bearing and an angle. Okay, so in compass surveying, I'm telling you in the whole chapter, what we are going to consider, or whatever the values which are given to you in the form of 109 degrees, 25 minutes, or 108 degrees, 45 minutes, etc. kind of thing, are nothing but the bearings. Please keep that in mind. Okay. So a bearing is the direction of a given line with respect to either true north or true south. In class loan, Alias. One. Okay. So the direction of a given survey line with respect to either magnetic north or true north is called as a bearing of the line. If you are measuring the direction of the line with respect to true north, it is called as the true bearing. And if you are measuring it with respect to magnetic north, it is called as the magnetic bearing. Okay. Suppose you take here the example of line AB. Okay. And the compass is centered at A. So what you will be doing, you will be establishing your instrument at A point, and you'll do all those temporary adjustments, centering, leveling, and focusing of the prism. And you'll rotate the compass in such a way that the ranging rod which is kept at the object B is sighted through the object vane. So you'll rotate the compass till the person carrying the ranging rod comes into your vision when you are seeing through the instrument. Okay, then you will then the pointer which is placed, which is available in the compass, to which graduation it directs here. Okay, we are having 180, 270, 0, 90 degrees, right? In between also you'll be having various angles, 180, 190, 200, 210, 230, like that. Again from 180 to 190, again you'll be having 3. Sorry, you'll be having 10. 180 to 181. 180 degrees, 20 minutes. 180 degrees, 40 minutes. 180 degrees, 60 minutes is nothing but 181 degrees. Again, 181, 20, 181, 40, 182. Again, 182, 20, 40, 183. So like that, you'll be having various graduations here in the form of 20 minutes interval. So wherever this line, the needle in the compass is pointing to the graduation, that is called as a bearing with respect to your north. But most of our calculations are with reference to magnetic north, because of the impact of the magnetic substances in and around our surfaces, the true direction is not possible for us. Okay, so for compass surveying, always keep it in mind, the measurements or the bearings which you are taking are nothing but the magnetic bearings. That is, we are taking with the values of the object with respect to the magnetic meridian, not with the true meridian or not with the true north. Okay. So this is how you measure the angles. So after the object B is completed, then suppose assume that the object C is at this point. Assume that the object C is at this point. What you will do? You will simply rotate the compass. Okay. With a slight gentle movement, you will rotate the compass till the object C is sighted from when you are standing from A, and when you are seeing through the compass instrument. Then again, what will be the value of this? The value of this is with respect to north, not with respect to B. Okay, so you need to measure it with respect to north, then it is called as bearing. But if you are measuring with respect to B, it becomes an angle. Assume that this is point C now. This is point C. So when I am measuring from north to C, it is called as the bearing. If I am measuring with respect to B, from B to C, this is called as an angle. Okay. But in compass surveying, we are going to measure only the bearings we are going to measure. But for calculation purposes, for calculating your areas, etc. kind of thing, you are going to derive what is the angle with respect to these between points. Then based on those angles, you will be calculating the areas. Okay. So there are two representations of this bearing. One is called as whole circle bearing and another is the quadrantal bearing. So you can see here, this is the north direction representing the true north. True north at a position doesn't change, and the true north at a position is fixed with respect to astronomical observations. That is, I'll take a sky, the stars available in the sky as my reference point, and I'll determine what is the latitude, longitude position at which I'm standing, and what is the direction at which I'm standing. Okay, so Earth doesn't change, as well as the position of stars in the sky doesn't change related to each other. So it is going to be forever as long as Earth is there. But magnetic bearing or magnetic meridian changes because of the rotation of the Earth as well as because of various other factors. Okay? So magnetic meridian changes from place to place, but true meridian or true north doesn't change. Today, if you are establishing a true north position of Hyderabad with respect to a star in the sky, it is going to be there till the Earth is alive. But magnetic meridian or magnetic bearing of a Hyderabad changes along the years, after 5 years or 10 years, because of changes in the rotation speed of the Earth, because of what we can say, some sunstorms happening in the space. Okay, because of some storms happening in the space, or because of high-end activities like high tension poles, or even excessive mining activity, can also reflect in changes of the magnetic bearings of the place. Okay. So this here, the north is the true north and east is the true east. So the measure, this is the line. Okay. So whatever measurement you are making for E with respect to north, it is called as the true bearing. And this is your magnetic north, this line. So if you are making measurements with respect to magnetic north, it is called as the magnetic bearing. Okay. And the difference between the true north and magnetic north is called as the magnetic declination. We'll see further. These topics are already there in your syllabus. I'll cover one by one, but I'm giving you the basic information now. So bearings measured with respect to true north are called as true bearings, which doesn't change with respect to time and space. Bearings measured with the magnetic north are called as magnetic bearings, which changes with time and place. Okay, and all the bearings which we are taking as part of our syllabus are by default magnetic bearings, and measurements are based with respect to magnetic north, not with the true north. Okay. So you can see a true north. There is a line AB. This is called as a survey line AB. So alpha is the true bearing of B from A. Beta is the magnetic bearing of B from A. Okay. So you need to have a clear concept here. What is true north? What is magnetic north? What is the difference? All those things. Okay. So we represent these bearings in two forms. One is the whole circle bearing system and other is the quadrantal bearing system. The whole circle bearing system is measured with respect to magnetic meridian or magnetic north in clockwise direction, and its values ranges from 0 to 360 degrees. The quadrant starts from north and progresses in a clockwise direction as the first quadrant is 0 to 90 in clockwise direction, second is 90 to 180, third is 180 to 270, and fourth is up to 260. See here. So you're starting at 0, 10, 20, 30, 40, 50, 60 like this. Again, you are coming back to 360. 60 and 0 are coinciding. So this one, first one is the first quadrant. This is north, east, west, south, west. I hope you are all aware of these directions, right? Right or wrong? Are you aware of the directions?
Yes, sir.
Can you tell me?
Yes, sir.
Yes, sir.
Can you tell me
Yes,
what is
sir.
the direction of our college main gate?
Huh?
What is the direction? In which direction our college main gate is existing?
West.
North
Huh?
side.
What? North?
West sir.
West side, sir.
Main gate.
Side.
Okay. Can you tell me what are the various other directions we have other than north, east, west, south? Let's go to Vastu for some time because that is very
Northwest.
important from our surveying point of view also. What do we call as northeast in Telugu?
ఈశాన్యం సార్.
Anyone.
Sir.
Eh?
ఈశాన్యం సార్. ఈశాన్యం.
Northeast. Okay, what is southeast?
నైరుతి.
Huh? Southeast is called as Agneyam.
దక్షిణాయనం.
South.
ఆగ్నేయం. ఓకే సార్.
Hmm? Agneyamena?
ఎస్ సార్. సౌత్ వెస్ట్ నైరుతి సార్.
Southwest is?
నైరుతి.
అంతేనా? ఇంకొకటి ఉంది.
Wow.
What is northwest?
Wow.
నార్త్ వెస్ట్.
So you have four directions. Basic directions is north,
Don't know,
south,
sir.
east, west, which you are all aware. So second is northeast direction. In Telugu we call it as Ishanyam. Okay. Then we have southeast between south and east quadrants at 45 degrees. Okay, it is called as Agneyam in Telugu. Then we have southwest. It is called as Nairuti, and northwest it is called as Vayuvyam. Okay. So these are the 8 directions which are important from a Vastu point of view also, because most of us follow the Vastu both from a traditional point of view as well as from the science point of view also, because based on the movement of the sun we will decide at what place the door should be there, at what place the other things should be there. Okay, this is the basic information you need to have in your mind. Okay, the whole 4 directions are again divided into 8 directions: north, northeast, east, southeast, south, southwest, then northwest and north. Okay, west direction. Okay, so in the whole circle bearing system what we are doing, it is represented in the form of 0 to 360 degrees. Okay, so if I want to measure what is the bearing of a given line, now see in the first figure, the center point is O. I have 4 lines: OA, OB, OC, OD. These are 4 survey lines which I am measuring by establishing my instrument at point O, which is the center point here. Okay, so in the whole circle bearing system what we need to do is we need to measure the direction of any of this line OA, OB, OC, OD with respect to north direction only. So here the theta, okay, the value of OA is from this north to this point. If I want to determine what is the bearing of OB, though the bearing of the line OB is in between south and east quadrants, this is south and this is east, but I need to measure what is the value of this from north direction only. See, I'm measuring from here to here. This is my north. Okay, this is for OA. From OA, from north, this is the bearing. For OB, from here, this is the bearing. Okay, when I come to this OC, okay, you can see here, this is the third one, small line here. Measuring the angle, the bearing of line or the direction of the line OC with respect to north direction only. Then OD, you can see here I'm measuring from north, this whole thing. Okay, so in simple, if you are using a whole circle bearing system, all the bearings of the given survey lines are with respect to north. So you can have values from 0 to 360 anything, 0 to 359 degrees. Okay, but if you come to a reduced bearing system or quadrantal bearing system, what we are doing here is we are dividing the whole again northeast west direction into 4 quadrants. Okay, okay, we are dividing it into 4 quadrants: northeast, southeast, southwest, and northwest quadrant. And each quadrant consists of values from 0 to 90 only. So now you see here, there are again 4 survey lines: OA, OB, OC, OD. Okay, the first survey line, any survey line in the first quadrant, the angular value will be the same for WCB, whole circle bearing, or reducer bearing. Here you can see this is 70 degrees from north. So the bearing of line OA is 70 degrees from north. But when you come to the second line, you see OB, I am measuring it with respect to south direction. I am not measuring with respect to north. In the earlier case, I have measured with respect to north, this one. But in the second case, reduced bearing or quadrantal bearing system, what I am doing, I am measuring what is the bearing of the line OB with respect to south direction. Okay. Again, OC also I am measuring from south direction because it is in third quadrant, southwest quadrant. Okay. South is my main direction, so I am measuring from south. When you compare to the fourth quadrant, you can see I am measuring from the north direction in the reverse direction. Okay. Actually, what happened in the earlier case for B, I'll just copy this also there. See, for D, I'm measuring from here to here. You are getting a very big angle here, almost in the range of 272. It is between 270 to 360 in between that. But in this case, what I'm measuring? I'm measuring from the north in the reverse direction. So I'm getting a less angle here. So the same value which you are observing the field can be represented either in the whole circle bearing system format or in the reduced bearing system format. The only difference is in the whole circle bearing format, the whole angle will be measured only with respect to the north direction. But in reduced bearing, you will be measuring the bearing in the quadrant which the line lies. If OB lies in southeast quadrant, you are going to give the representation as south 35 degrees east. Okay, for OA, you are going to representation as north 70 degrees east because it is in the quadrant northeast, the value is 70. South 35 degrees east because it is in the southeast quadrant and the value from south is 35. If you come to OC, we'll represent it as south 55 degrees west because it is in the southwest quadrant. When it comes to fourth quadrant, it is north 30 degrees west. Okay, from north it is 30. Here from south it is 55. Here from south it is 35. Here from north it is 70. So you need not confuse here. Just you check in which quadrant your survey line is falling and measure the values only from either north direction and south direction. Okay, the first letter in your quadrantal bearing should definitely be the first alphabet in your quadrantal bearing or reduced bearing should definitely be either N or S. And the last letter will be either E or W. You will not get anywhere N and S, N at the starting and S at the ending. It will be either NE or SE, SW or NW only. Or sometimes it will be N0 and S0, that is north direction and south direction. Okay. So how to convert one system to other system? Suppose I have an angle of 340 degrees. Okay. The whole circle bearing is given as 340 degrees. That is with respect to north. Okay. The survey line value is 340 degrees. So 340 means in which quadrant it will come? The whole circle is 360. So the
Fourth quadrant.
bearing value is 340. So which quadrant?
Second quadrant.
340.
344th quadrant, sir.
Okay, first quadrant is 0 to 90, second is 90 to 180, third is 180 to 270, and fourth is 270 to 340, 360. Okay, so my angle is 340, so it falls in fourth quadrant. Okay, now what will be the reduced bearing now? So 340 is from north, right? So from here, it is 340. So what will be the difference between this survey line and north direction now? 360 minus 340, right?
Yes, sir.
Okay. So how will you represent now the bearing of line falling in fourth quadrant? North 20 degrees west. Okay. So similarly, if the value of survey line is 80 degrees, the whole circle bearing of survey line is 80 degrees. Which quadrant it falls?
First quadrant.
First quadrant. So what will be the quadrantal bearing? North 80 degrees east.
North.
Right?
Yes, sir.
So assume that now the value of a bearing the bearing of a line is 135 degrees. So which quadrant it will fall in reduced bearing?
Second quadrant.
Second quadrant. So what will be the reduced bearing now?
180
I'm saying the
minus
whole
135.
circle bearing is 135.
Yes, sir.
Okay, so from north it is 135. So up to here it is 90. From 90 it is 45. Right? So what will the remaining balance? 45, right?
45.
What? So it will be south 45 degrees
45 east.
east. Okay. So like that you need to convert one whole circle bearing system into reduced bearing, or if suppose you have been given reduced bearing values, then you can convert into whole circle also. Suppose assume that the reduced bearing value given is south 60 degrees west. What will be its whole circle bearing? South 60 degrees west. That is, the survey line is here at a point of 60 degrees. So from north to south it is 180 degrees, and from 180 you add 60 degrees. So it will be 240 degrees. Okay. So this is how you need to convert from one system to the other system. There are some equations also which you can remember if you want. But my suggestion, sincere suggestion is don't remember these equations. Because
Sir?
you know the quadrants. Okay, this is
Sir?
the basic. Yeah.
Sir, it's little confusing, sir. Once again, you explain no conversion.
We will solve some problems and you'll be able to understand clearly. Okay.
Okay, sir.
So, but my sincere suggestion for you is you don't remember the equations. You know the 4 quadrants diagram, you know it, right? North, east, west, south, you can divide. Okay, 2 lines, 1 vertical line, 1 horizontal line. Rasi, where is north, where is east, where is west, where is south, and we maintain chegaltaru. Okay. So from there you draw the line. Given angle ఎంత అయితే ఇచ్చారో ఆ యాంగిల్ లైన్ డ్రా చేయండి. డ్రా చేసినప్పుడు మీకే తెలుస్తుంది అది ఏ క్వాడ్రంట్ లోకి వస్తుంది అన్నది. దాన్ని బట్టి యూ కెన్ ఫైండ్ అవుట్. ఓకే. But for your reference, I'm giving you here the table. Okay. So if the whole circle bearing value is between 0 to 90 degrees, the quadrant it lies is northeast quadrant. If it is 90 to 180, okay, the reduced bearing in the first quadrant, the whole circle bearing value is equal to the reduced bearing value also. Okay, your WCB and RB. Okay, if it is 0 to 90 is the WCB, whole circle the reduced bearing value will also be 0 to 90 only in between. If the whole circle bearing value is between 90 to 180, that is in the second quadrant, and if you want to get the reduced bearing, you need to subtract the whole circle bearing from 180, and it falls in the southeast quadrant. If it is between 180 to 270, subtract whole circle bearing minus 180. If it is between 270 to 360, subtract 360 minus whole circle bearing in order to get the reduced bearing. Okay. And similarly, you have a conversion from RB to WCB. If RB is in the northeast quadrant, whole circle bearing is equal to the reduced bearing 0 to 90. If it is in the southeast quadrant, whole circle bearing is equal to 180 minus RB. That is, it falls between 90 to 180. The value of whole circle bearing will be between 90 to 180. And if it is southwest, you add 180 degrees to the reduced bearing, you'll be getting the whole circle bearing. And if it is northwest, you subtract the reduced bearing from 360, you'll be getting the whole circle bearing. I can understand this thing will be a bit complicated and confusing, but as long as you don't solve the problems, you'll not be able to get a grip on this. Okay. So let's solve some problems.
Sir, why you are saying not to remember the equations, sir?
Suppose instead of subtracting, if you add,
Okay. Sir.
instead of here you see full circle bearing is equal to 180 minus RB. By mistake, if you have done it as 180 plus RB,
Yes, sir.
without knowing the without drawing the diagram, can you give me an assurance that what calculations you have done is right? So there is a scope
sir.
for confusion. But if you draw a diagram like this, okay, if suppose you are getting a value as 210 degrees, okay,
Yes, sir.
assume that you got a value of 210 degrees by your calculations and the actual line lies in the second quadrant. Is it correct? Because the maximum angle till the second quadrant is only 180 degrees, right? It can't, any line
Yes,
can't
sir.
be 210 degrees between this second quadrant. So here you can easily identify whether you have done it correctly or wrong. You can remember the equations. There is no restriction on that, but there is a scope for doing some mistake. And I am telling from the exam point of view, because you'll have a limited time of 10 minutes or 15 minutes to solve the problems. Okay. So if at all in a hurry you have done a mistake, your whole problem goes wrong. But if you draw a diagram like this, then you can assess yourself whether you are doing it correctly or wrong. That is the reason why I am telling you to remember this diagram rather than the equations. Okay, and it is up to the convenience of the students. ఇప్పుడు కొంతమంది బట్టి పట్టే వాళ్ళు ఉంటారు, నో ప్రాబ్లం, వాడికి ఇదే ఇతనే ఈజీ ఉంటుంది, ఇట్లా గుర్తుండిపోతుంది వాళ్ళకి మెదడులో 180 మైనస్ ఆర్బి 180 మైనస్ ఆర్బి. సో నాట్ ఎ ప్రాబ్లం. బట్ if you are thinking logically from the concept point of view also, I suggest you to remember this diagram instead of the equations. Okay, if this diagram is in your mind, then you can solve any type of problem. That is what I want to convey. Okay,
Okay, sir.
so let us do some simple problems. Okay, I am giving you the first question. Convert the following whole circle bearing into reduced bearing. 49 degrees. So where does 49 degrees come?
First quadrant.
First quadrant. First quadrant or second?
First.
First
First
quadrant.
quadrant.
First, sir.
I'm hearing some answers second quadrant. 49 degrees north నుంచి measure చేయండి. First quadrant is 0 to 90. Second is 90 to 180. Third is 180 to 270. Fourth is 270 to 360. ఇది మన చిన్నప్పటి నుంచి నేర్చుకుంటున్నాము quadrants. Whole circle is 360 degrees. I hope you all agree or not.
Yes, sir.
Okay, so when the survey line is having a bearing of 49 degrees, it means it comes in the first quadrant. See here. So what will be the quadrantal bearing or reduced bearing of this now?
North to west, north to
North.
west.
North 49 degrees east. It is coming in the northeast quadrant, right?
West,
Yes, sir.
east.
Okay. So now take the example of 240.
Third quadrant.
240, third quadrant.
Third quadrant, sir.
We would have explained it in a better manner if it is a classroom, but here. See here. Are you able to see the picture clearly?
South is that.
Yes, sir.
Okay. 240 degrees. Okay. The line falls in the third quadrant. So which is the nearer to this line now? South and west are
degrees
nearer,
west, sir.
right? Okay.
Yes, sir.
So from north, the value is 240. Okay. Up to south, it is 180, right? Up to this south direction, it is 180. So what is the
Yes,
balance
sir.
here? From south, it is 60 degrees, right?
60.
So it is south 60 degrees west.
Oh, okay, sir.
Okay.
Yes, sir.
So now let's take the next example, 360 degrees. Sorry, it is 335 degrees. Let us take 335 degrees.
North 25 degrees west.
So 335 means it falls in the fourth quadrant from north direction. From north direction, it is 335 degrees. So it is coming in the fourth direction, fourth quadrant. Okay. So what is the value from north now? In the reverse direction? 360 minus 335. So it is 25.
25.
So in which quadrant it is there?
Second
Northwest it is
quadrant.
there. So the answer is north
West.
25
25
degrees
degrees
west.
west.
Okay. Now let us see the another one. Convert the whole reduced bearings into whole circle bearings. So north 65 degrees east. So which quadrant it is? 65 degrees is the angle.
First quadrant.
First quadrant.
First quadrant.
Yeah. It is
First
in
quadrant.
between north and east, so it comes in the first quadrant.
First quadrant.
So when a line falls in the first quadrant, what will be its whole circle bearing? When line falls in first quadrant, the whole circle bearing is equal to quadrantal bearing, or quadrantal bearing or reduced bearing is equal to whole circle bearing numerically. Okay. So since it is in the northeast quadrant, alpha is equal to 65 degrees. Whatever value you are seeing here, the same will be your whole circle bearing. Okay. Now the second one is south 43 degrees 15 minutes east.
23
So where it
degrees
is lying?
15 seconds.
Southeast.
So this is your
Second quadrant.
this is your northeast west south. So what is the value is saying? South 40 degrees 15 minutes.
Southeast, sir.
No, he has given it as southeast. I'm asking you what is the whole circle bearing. So this angle is 43 degrees 15 minutes. Okay. As per the given question. Up to here.
Sir, 137 degrees 70, 137 degrees 75 seconds.
Up to here it is 43 degrees 15 minutes with respect to southeast. But what is whole circle bearing? The bearing of
180
this line
minus
with respect to
43
north.
degrees 15 minutes.
So I want to determine what is the angle from here now.
Sir, 136 degrees 45 minutes, sir. 136 degrees 45 minutes, sir.
Yeah, that's the right answer, but I'm explaining you. Just wait. Okay. So what will be the angle from here? From here to here it is 90 degrees, right?
Yes, sir.
Up to here it is 90. What is this angle? This whole angle is 90, right? So this angle is
sir.
equal to 90 minus 43 degrees 15 minutes.
15 minutes.
Okay. So you'll get some value. So you just add that value. How much you are getting? 136 degrees 45 minutes will be your value. Simply, if you want to determine this from here to here, it is 180. Subtract this 43 degrees 15 minutes. The rest of the value gives you the whole circle bearing. Okay. So now what will be the answer for north? 32 degrees 42 minutes west. So this angle is 32 degrees 42 minutes from this north and west line.
327 degrees 18 seconds.
So from here I need to measure. So I can add 90 plus 90 plus 90 and plus 90 minus 32.42 or simply 360 minus 32.42. Okay. The answer is 327 degrees 18 minutes. So can you do the same thing using the equations now? Remember those equations and apply. It's a bit difficult. So that is the reason why I'm saying please draw the diagram. Whenever this type of question is given, draw the diagram of the quadrant, then try to represent that in the pictorial form. Then you will be able to easily solve the problem. Okay.
Yes, sir.
Yeah, take this as an example. No, this is not required. So is this concept clear?
Yes, sir.
Yes, sir. Clear.
Yes, sir.
Yes, sir.
A quick answer I want now from you. Convert this whole circle bearings into reduced bearings. 190 is the whole circle bearing.
Sir, 10 degrees, sir.
No, reduced
Sine.
bearing should definitely be represented with either north, east,
South
or
10 degrees.
South 10 degrees.
South 10 degrees west.
South 10
Okay.
West.
Yeah, just give a chance to others also. Let me wait. Who is the most mischievous guy in your class?
Rahul, sir.
Rahul,
Vatsalya?
sir. Rahul, sir.
Vatsalya? Yeah, tell me the answer for 315 degrees. The whole circle bearing is 315 degrees. What is the reduced bearing? Which quadrant 315 degrees comes under?
260,
First tell me in which quadrant 315 degrees comes?
4,
Fourth quadrant? Are you there?
sir.
So in which quadrant 315 degrees comes?
4 అనుకుంటున్నా సార్.
4 అనుకుంటున్నావా? నువ్వు స్కూల్ చదవట్లేదమ్మా, ఇంజనీరింగ్ చదువుతున్నావు. One quadrant is equal to 90 degrees. So 315 comes under 270 to 360 band. That is the fourth quadrant. So what will be the reduced bearing of 315 degrees now?
Repeat sir, మళ్ళీ అడగండి ఒకసారి.
Any other who can respond?
Sir, north 45 degrees west.
45 degrees northwest.
Then sir.
సార్ మీరు 360 అన్నారు కదా సార్?
45 degrees.
360 అన్నారు కదా సార్? మీరు 360 అన్నారు.
315, see the screen.
315.
నార్త్ 44 degrees west
Sir,
సార్.
north
North 45 degrees west.
Okay, what is the reduced bearing of 260 then?
South 80 degrees
South.
west.
South 80 degrees west.
West.
Okay. Yeah, okay. So I'll stop here. I think we are done, right? 120. So please, there are only 25 members. Why strength is very less?
I don't know,
Online.
sir.
ఫీజులు కట్టమనేసరికి అందరు మానేస్తున్నారా?
No, sir.
Okay, tell me your attendance.
7.
7,
3
8,
3 1
3, 1,
2 sir.
2,
14,
14,
11,
10, 11,
14 sir.
14 రాశాను. రాశాను. 10, 11,
9 sir.
9,
16,
16.
14 sir.
19 సార్.
ప్రియాంక నువ్వు ఇంకొకసారి అటెండెన్స్ ఇస్తే అబ్సెంట్ చేస్తా. చెప్పాను ఆల్రెడీ వేసాను అనేసి. కనపడట్లేదు స్క్రీన్ అక్కడ.
సార్ 19
19, 37,
49
సార్.
sir.
23 సార్.
49, 23,
22 sir,
24, sir.
24,
22 sir,
22,
21,
21, 39,
32 sir.
53 sir,
32,
28
53
sir.
sir,
33. 33 ఉన్నాడా?
Sir, 53 అంటారు సార్, 33 కాదు సార్.
ఓకే, 53,
51.
51, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. Okay then. Thank you and bye for the day.
Thank you, sir.
థ్యాంక్ యూ సార్.
Okay.
Abhishek.